Good morning, everybody, and welcome back to another exciting lesson here in Algebra 2. I'm Mr. K speaking. Alrighty, 5% battery left. Let's go. Okay, so this particular lesson, kind of goes, I wouldn't say it's similar to, but like the process is very similar to our difference of two squares problems. Okay, so in this particular lesson, we're going to be looking at the sum of perfect cubes and the difference of perfect cubes. Okay, what do I mean by the sum of perfect cubes? Well, if you look down here, we are adding two perfect cubes, right? And the difference of two perfect cubes will look just like this. Okay, so with our dots problem, we only had difference of two squares. Okay, with perfect cubes, there's actually two ways these things break down, so that when you factor these two things, okay, they each have their own set of formula, if you will. All right, so let's talk about a perfect cube at first. Okay, so a perfect cube, all right, if you do not know what I'm talking about, is just some number multiplied by itself 3 times. Okay, so 2 cubed, or 2 cubed is actually 8. All right, 3 cubed, 3 times 3 times 3 is 27. 4 cubed, 4 times 4 times 4, 64. Okay, and so the more you do these things, you start to kind of remember, those numbers start to kind of stick out a little bit. But in the beginning, you might have to use your calculator just to make sure that, hey, are these perfect cubes that I'm looking at? Okay, and so until you get comfortable with those, it might take some time. You might have to use your calculator a little bit to just make sure to verify these are a perfect cube. So anyway, what am I talking about here? So just like your difference of two squares problems, okay, if you recall difference of two squares, a squared minus b squared, okay, when you factor this, you get a plus b, a minus b, okay? The sum of perfect cubes and difference of perfect cubes kind of very similar in the sense that they have some way you can factor these things and break these things down. So let's look at the sum of perfect cubes first. Okay, so first you want to be able to spot, okay, so you got some number cubed plus some number cubed. If you have that, then you can factor it into this expression right here. Okay, so whatever your a value is will go in there for a, whatever your b value is will go in there for b, so a plus b times a squared minus ab plus b squared. Okay, so when you can spot these sums of when you're adding two perfect cubes, you can break it down and factor it right into this, okay, and then you're done. That's it. Okay, you won't go on any further. Right? In most cases, it's already that's the final factor right there. Okay, which is nice. So you spot these things. Okay, you can factor them rather quickly and move on. Okay. So let's look at the difference of perfect cubes. Very similar, except obviously there is a subtraction sign in between, okay? Hence the name difference. All right, so when you spot the difference of two cubes, okay, you can break it, you can factor it into this expression, okay, which looks very similar to the other one. So you're going to have to try to memorize where these addition and subtraction signs go, okay? What I try to do is I try to remember, okay, this one's always going to start out a minus b, because it's the difference. And then the rest of them are all plus signs in between. So a squared plus ab plus b squared. Over here, all right, starts out a plus b, because we got the sum there. And then in between that a squared and ab is a subtraction sign. So it's a squared minus ab plus b squared. Okay, so until you get comfortable with these things, you might have to keep scrolling up to look at the expression here, okay, which is fine. Okay, until you get comfortable with it, I expect you to do that. Okay, so let's take a look at the first one here. Okay, so it says factor completely. All right, now because this is a perfect cubes lesson, I know that these are going to be perfect cubes, but let's just talk about them, right? We know this is a perfect cube, okay, because it's some number, some arbitrary number. Arbitrary just means it can be anything. We don't know what it is, but we do know it's being multiplied by itself 3 times, okay? That's what that 3 in the corner signifies. Now we have to take a look at this one. You have to determine if this is a perfect square, which it is. That's 3 times 3 times 3. Okay? So what you can do, sometimes this helps, okay? Let me write down the formula here. So a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared, okay? If you would like to, you can label, okay, well in this case, our a value, what's being cubed, is just x, and our b value, what's being cubed, is just 3. And then you can just fill in the blanks, right? We can go x minus 3, and then the other set of parentheses, x squared plus 3x plus 3 squared, which is actually just 9. And because this is an expression, that's it. We can't do anything else with it. And as you can see, we can't factor this problem anymore. All right, so if you look at 9, the factors of 9, okay, we definitely cannot get a 3x out of those numbers. So we're done, and that's it. So let's move on to the next one. Okay, this one has a plus sign in the middle. Hence, this will be a sum of perfect cubes. So the sum of perfect cubes, again, it's equation, or not equation, I'm sorry, it's the expression, when factored, will look like this. Okay, so in this case, we know our a value is just going to be x, and our b value here is going to be 10. Right, so if you think about it, 10 times 10 times 10 is 1,000, which is just 10 cubed. Okay, so you don't have to do this thing with AB. Okay, sometimes it's just nice to kind of separate that thing out, and then you can just plug these values right into the expression. So I just go x plus 10. You go x squared minus 10x plus 10 squared, which is 100. And we're done. Okay, let's move on to the next one. Okay, so in the first two, I kind of skipped over your first important step when you're going to factor expressions, and that is take out a GCF. Okay, the first two we couldn't take out a GCF because we didn't have variables on either side of the, well, as you can see, we just couldn't take out a GCF, right? So here we can, and so it's still advisable to do so. Okay, so the GCF here is going to be a 5x. So take out a 5x. That leaves me x cubed plus 8. All right, and so now I take a look at this expression and I say, okay, can I take this down any further? All right, so this is one more thing you got to look for. All right, this isn't a difference of two squares problem, right? Because it's got a plus sign, we got an x cubed, okay? But this is a sum of perfect cubes, okay? So don't forget, this is a cubed plus b cubed is equal to a plus b, a squared minus ab plus b squared. Okay, so we just break that down. So we go 5x. Our a value here is just x, and our b value here is 2, right? Because 2 cubed is, is 8. 2 times 2 times 2 was 8. Okay, so your a value is x, your b value is 2. So we go x squared, minus 2x plus 4, right? 2 squared is 4. And that is it. Let's move on to the next one. Okay, so here we go. Again, can we take out a GCF? All right, no, there's no GCF here. Okay, so our next move is we have to verify whether this piece and this piece are perfect cubes. Okay, so we know 27 is just 3 times 3 times 3, which is 3 cubed. Okay, we know x, we don't know what it is, but we know it's being cubed, right? So this is just x times x times x. All right, so the first one is a perfect cube. So actually, our a value here, for this one right here, is going to be 3x. Right, so if you think about it, 3x cubed will give you 3 cubed, x cubed, which is going to be 27x cubed. So we're good there. Okay, so our a value is 3x. Our b value, let's take a look. Okay, so our b value, well, we know 8 is just 2 times 2 times 2, which is 2 cubed. So we know our b value is going to have a 2 in it. And then also we got a y there. We don't know what it is, but again, it's being cubed. So our b value is y, or 2y, sorry. Okay. So now, again, our equation was a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. Okay, so this is where it kind of helps to have these a and b values, because we're going to have to do some extra multiplication once we fill these things in for our expression here. Okay, so we're going to go 3x minus 2y. Okay, that's going to be in the first parenthesis. Our next parenthesis, notice I'm going to leave these in here, so it's going to be 3x squared plus 3x times 2y plus 2y squared. Okay, all I did was I took these values and I just filled them in the expression here. Okay, now it might seem a little messy, and maybe you're like, well, I can just do this math in my head. You can, okay, but just be aware that you got to account for all those squares in there. Okay, so 3 squared is going to be 9. X squared is just x squared. Okay, 3 times 2 is going to be 6, then just xy. And last but not least, 2 squared is just 4y squared. And we are done. Oops, forgot. There we go. Almost done. Now we're finished. Okay? All right, so that is a much more complex version of a complete difference of perfect cubes. Okay, we've got 3 more problems here. All right, so this one here, probably thinking, I don't know, they look like 6s, not 3s. That is true. Okay, but let's think about this for a second. All right, w squared, okay, cubed. All right, if you remember your rules of exponents, okay, power raised to another power. So we got w squared times w squared times w squared. It's just going to be w to the 6. Okay, so we do have a difference of perfect cubes here. And z is going to be the same thing. Z squared raised to the 3rd power is just z squared times z squared times, whoops, z squared is equal to z to the 6. Okay? So, here we go again. So we're going to go a cubed minus b cubed. I'm just going to keep writing this for you. I'm a nice guy like that. Okay, so we're going to fill in the blanks here. So in this case, our a is w squared. Our b is z squared. Okay, so we're going to go w squared minus z squared. W squared squared plus w squared times z squared plus z squared squared. Okay, so there we go. Let's fill in the blanks here. So w squared minus z squared, w to the fourth plus w squared, z squared plus z to the fourth. Whew! Done. Okay? Another tricky one here. You got to recognize, and this one it kind of made us use our rules of exponents. Okay, to kind of we had to go back and remember what that meant. All right, and so don't forget, you get a power to a power. These two things multiply together. Okay, let's look at number 6. Down to 3%. Oh boy, it's getting close. So, a great opportunity, if you didn't see it already, take out a GCF. Okay? Now, 81 is divisible by 3. If you guys want to know a little trick about 3's, okay, add these two numbers up. They're divisible by 3. Or if it's a number divisible by 3, then it's divisible by 3. So 81 divided by 3 is 27. Okay? So I'm going to take out a 3. I'm also going to take out an x squared and a y squared, because why not? They both have them. I want to take out everything, right? So I take out everything. And I'm left with x cubed and y cubed minus 27. Okay? So if that didn't make you grin already, it should, because this is going to be a difference of perfect cubes. Okay, we already know 27 is a perfect cube, and as we can see, x cubed and y cubed are just some numbers cubed, right? So if you think about it, if you remember your rules of exponents, xy cubed, okay, this distributes to both variables. Okay, so our a value is xy, and our b value is 3. Okay, so now we break this down. So we're going to go 3x squared, y squared. Because it's a difference, I'm going to start out with xy minus 3. Probably going to need that longer. So then it's going to be xy squared plus, I'm just going to go 3xy, and then plus 3 squared, which is 9. And I'm going to simplify this further right here. Okay, so I'm going to go 3x squared, y squared. Make sure, well, I guess that's all multiplying. I'll put that in parentheses anyway. It wouldn't be wrong, but it just kind of makes things a little more organized. So there's x squared, y squared, plus 3xy, plus 9. Whew! Problems are getting beastly. But as long as you can recognize what your a and b value is, and whether it's a difference of perfect cubes or a sum, you just plug it right into that little formula-like expression that we have at the top of the page. Okay. Now this one looks way different than all the other ones we did. Okay. This one is going to have to involve factor by grouping. All right. It just has to be. So, I'm assuming, though, that when we're done factoring by grouping here, we're probably going to be left with some sort of sum or difference of perfect cubes. Just guessing. But I could be wrong. Let's take a look. So, I'm going to take out a GCF from, remember this is factor by grouping. Okay, so I'm going to take out an x to the 6. Then I'm going to be left with x squared minus 4. Oh, and then whoops, I'm doing it all wrong here. Okay, what am I going to factor out here? It's 27, 108 divided by, that's what I thought. Yep, 27 goes into 108 4 times, so I'm going to take out a 27, take out a positive 27. I'm going to be left with x squared minus 4. Perfect. So now I'm left with x to the 6th plus 27. X squared minus 4. Now some of you are thinking, God, I hope this is done. Some of you might be jumping out of your seat. There's a couple things we got going on here. Okay. First thing I'm noticing, we have a dots problem right here. Difference of 2 squares. Okay. So let's take care of that guy first. So the difference of 2 squares, we're going to go, whoops, x to the 6 plus 27. X plus 2, x minus 2, right? Okay? This is the difference of two squares problem. Hope you guys remember that expression. Now this next one is going to be a sum of perfect cubes. Okay? So let me give myself some more space here. All right? So, don't forget x squared raised to the third power is x to the 6th. So our a value is x squared, and I see a 27 there, so I know my b value is just 3. So then I go, because this is a sum, so I'm going to go x squared plus 3. Then I'm going to go x squared squared plus 3x squared. Plus 3 squared. We'll simplify. Forgot these other things here too. Here we go. X minus 2. There's that. Can't forget everything. And then finally, x plus 3, parentheses, x to the 4th minus 3x squared plus 9, x plus 2, x minus 2. That is it. With 2% to go, I think we made it. All right, guys. Try to follow along with this homework here. And any questions, make sure to bring those to class, okay? So I do have 10 questions here, so I'm going to do what I did in the last homework, okay? Blue group, you got the odds. And red group, you got the evens. All right. Good luck, you guys. Any questions, send me an email.